Now, let's go to 22. We're given a polynomial 4x cubed minus 64x squared plus 196x that represents the volume of a box, where x is between 0 and 7. We have to evaluate the polynomial two values at 4 and at 6 and interpret our replies, our answers. So p at 4 will be equal with 4 times 4 cubed minus 64 times 4 squared plus 196 times 4. Plug those values into a calculator. We get back the value 16. Now let's plug in 6 as well, and then we will interpret both answers together. So we get 4 times 6 cubed minus 64 times 6 squared plus 196 times 6, which gives us back negative 264. Now for the first one, the answer is when x is equal with 4, the box has volume 16. Equal with 4, the volume is 16. For the second one is that the volume could not possibly be a negative number. The idea here is that x cannot be 6 if the polynomial represents volume. That is, the model is either incorrect or it represents something else. The last exercise, we are asked to give examples of polynomial of degree 5, where one has 4 turning points and one has 2 turning points. For your problem, it is 3 and 1. So let's start with the polynomial of degree 5. In either case, we will need to be of the form ax to the 5th plus something to the 4th and a constant term. That is a legitimate way to try to create a polynomial like that, but it will not help us on the turning points. Another way to do is, as in exercise 20, we can have a polynomial factored and still be able to find the degree. If we have 5 linear terms, then the polynomial is of degree 5. If we have 2 linear terms, it is of degree 2. If we have a quadratic term and a linear term, it is of degree 3, the highest term of each parenthesis. So now the turning points, as mentioned in the lectures, can be up to 1 less than the degree, and that only happens if we have as many roots as the degree. So for polynomial of degree 5 with 4 turning points, we need essentially a polynomial of degree 5 with 5 different roots. So the easiest polynomial to go for here will be x plus 1, which has a root at -1, x plus 2, which has a different root at -2, x plus 3, plus 4, and plus 5. We just need to have different numbers here to make sure all the roots are unique. And then we have 5 linear terms, so the polynomial is of degree 5. The turning points are equal with 4 because I have exactly as many solutions as my polynomial. The second part is a little bit trickier because it doesn't have a standardized way to go. The problem is that I don't have neither as many turning points as the degree -1, nor just 1 turning point. I have 2. The idea here is if you have an odd degree polynomial, you can start with an even degree polynomial. The easiest one to start, even degree polynomial with 1 solution as a factor, will be x to the 4th. This will be looking like a parabola, is the idea. When I add 1 factor here with a different, of course, solution, not just x plus 1, x minus 20, x plus 1,000, doesn't matter as long as it is not the same solution as the previous one, then I create 1 extra turning point. Why is that? Because I create a solution where previously the polynomial was looking like this, and let's assume that it still does on this part, because I multiply with something positive since I'm above -1. Now, it used to do something like that, but now we foresee that at -1, it needs to go back at 0. So it creates a new turning point over here, apart from the turning point we had. This one was from the x to the 4th. This one, now that we force the parabola to bend and be a polynomial of degree 5, which we know that -infinity will go to -infinity since the leading coefficient is 1, we force it to create another turning point here. And similarly with experimentation, we can create a degree with 3 turning points and 4 turning points. Depending on how many turning points you're asked to have, you start with a polynomial of appropriate lower degree. For example, if we were asked to find of 3 turning points, I would either start with a square or a cube to give me enough space to create more factors, but not too low as to have a problem with exponents on the factors. Just enough. Since I wanted 3 turning points, I would go either to square or to cube. That is because from square to get to the 5th power, I need at most 3 terms, another 3 terms. So that is a good guess. If it doesn't want, then I go to cubic. Similarly, if we were asked a polynomial of degree 70 with 63 turning points, I would start from degree 7 and above, or 6 and above, to have enough space to fit all the turning points I need as terms, but not too low. I'm going to start from x squared, because then I might have a problem with increasing the exponents on those turning points, which might cause them to not contribute as we wanted to. That will be all for today. I wish you a great week.